Section 1.2 looks at slopes in the plane. This should also be a review, so I'm going to breeze through this. The slope of a non-vertical line represents the number of units the line rises or falls vertically over each unit of horizontal change from left to right. What that's really saying, you've probably seen this before, slope is equal to rise. So slope, which we call m, is equal to our rise over our run. So we say how many it goes up or down over how many it goes left or right. So the vertical change over the horizontal change. So the slope is denoted by the lowercase m. So for the line that passes through the point x1, meaning the first x value, y1, meaning the first y value, and the point x2, y2, so a second point, the x value and the y value, we would write the slope as m is equal to change in y over change in x. This little triangle is called delta. So I made a note of that over here. Delta is equal to the change. So I would subtract the y's on top and then subtract the x's on the bottom. So x2 minus x1, I'm sorry, y2 minus y1 over x2 minus x1. It really doesn't matter which point you call point 1 and point 2 as long as you're consistent. So it says make sure your points match up. And what I mean by that is if you have y2, then x2 needs to be the first one in the denominator. If you start with y1, then x1 needs to be the first one in the denominator. Notice here the x2 is over top of, I'm sorry, the y2 is over top of the x1. That's not matching up. That's the only thing you need to be careful of when you're working with that. Okay, so I'm going to look at the first example. It says find the slope of the line passing through the points -1, 2, and 2, 2. So first thing I'm going to do is write out my formula for finding slope. So slope is equal to change in y over change in x, which remember means y2 minus y1 over x2 minus x1. Just a refresher for myself, this is x1, this is y1, and this is x2, this is y2. Again, I could do this, swap these around, this could be point 2 and this could be point 1, and I'd still get the same answer as long as I'm consistent in setting it up. So I'm going to move these back just for the sake of the first point that showed up and the second point that showed up. Now I'm going to substitute the points. So instead of y2, I'm going to put a 2 minus, notice I'm going to use parentheses when subbing in here. That's going to help me if there's negative values. I'm not going to make any mistakes, hopefully. So y1 is 2 over top of x2 is 2 minus x1 is -1. When I simplify that, obviously I'm looking at 2 minus 2 is 0. 2 minus -1 is really 2 plus 1. I'm left with 0 divided by 3, which is just 0. So in this case, the slope is 0. This is a special scenario here. We're going to look at the 4 types of slope next and how we can identify slopes that are 0 right off the bat by looking at a graph. So there are 4 types of slope. The first is positive, and that's when m, so our slope, is greater than 0. This means it rises from left to right. So I'm going to draw a quick sketch over here. Anything where the slope goes up as I go from left to right. Okay, some people have looked at a little skiing guy, and you would say he's skiing uphill here. It says puff, puff, positive. He's working hard to ski up the hill or working his way to run up the hill, and so positive slope. Okay, it's getting higher as it goes across. Positive slope. A line that falls from left to right is negative, meaning the slope is less than 0. So on a graph, that would look something like this. Sometimes people who use that ski analogy are looking at a person who's skiing down the hill, which is nice and easy, doesn't take a lot of effort, nice, negative. The height is getting smaller as the x gets larger, a negative slope. The next is a 0 slope, so the slope is literally equal to 0. We just saw that. And that's any horizontal line. Horizontal meaning goes across. So a horizontal line has a slope of 0, just a straight horizontal line. And then the last one is a slope that's undefined, and that would be any line that is vertical. So I just want to make a note. These are all y equals lines, and these would all be x equals lines. So anytime you see x equals 3, vertical line, undefined slope. Y equals negative 37, horizontal line, 0 slope. Just something to put in your notes to have for future reference. This right here looks at all 4 types of slope. You can add this in. Up, right here, we're looking at a positive slope. Dropping down is a negative slope. Straight across is 0. And then when you fall off the cliff, it's undefined. UND is undefined. If you don't know what that means and won't go back and remember that, you should make a note here that this means undefined. Point slope form, so we've looked at y-intercept or slope-intercept form, that was in 1.1, but point slope form is when you're given the point and then a slope, and you can write an equation for that line. So point slope form of equation passes through the point x1, y1 has a slope of m. This is your formula. So that's what you want to note for future reference. That's what you want to keep track of. Star y minus y1 is equal to m times x minus x1. These points are going to stay the same. You need an x and a y in an equation. So this x and this y are going to stay, and then we're going to plug in our points elsewhere. So the example says, find an equation of a line that passes through the point 1, negative 2, and has a slope of 3. So first thing I'm going to do is write my formula. So y minus y1 is equal to m times x minus x1. In this case, x1 is 1, y1 is negative 2. So I'm going to sub in the points. Y minus, I'm going to use parentheses so I don't mess up my signs, is equal to my slope, which is right here, so m is equal to 3, times x minus 1. Notice I kept the x and I kept the y. I need an x and a y. That's going to stay in my equation. If I wanted to graph this, I could do 2 things here. I could plot the point 1, negative 2, and then go up 3 and over 1. Or I can put it in y equals mx plus b format, and that's what's going to happen here. So really I have y plus 2 is equal to 3 times x minus 1. If I distribute this 3, I'm looking at 3x minus 3. Subtract the 2 from both sides. And in slope-intercept form, I realize my equation is y equals 3x minus 5. So these 2 equations are exactly the same. They'll give me the same graph. It's just a different format. So think about a $5 bill and 5 singles. They're worth the same thing, they just look different. That's what you're looking at here. This is point slope. And our bottom one is slope intercept, which we saw in 1.1. We're going to save this linear model profit prediction example for in class. So you can skip ahead to sketching graphs of lines. So first thing you do when you're going to sketch the graph of a line, if you have another system that works for you, by all means, if you like to use the intercepts, if you're fine using point slope, but I'm just going to use slope intercept. So we're going to get the equation in y equals mx plus b format. We're going to determine the y-intercept and then determine the slope. So you'll see I made a note here. B is the y-intercept and m is our slope. Over here you're looking at all the different types of lines. So your general form, a vertical line, which we just talked about, a horizontal line, slope intercept, and point slope. So there's all of them in one nice chart. That's right out of your book. Okay, I'm going to graph the line x plus y equals 2. I'm going to use the same process we used before, and I'm going to get y by itself. So I'm going to subtract x on both sides. I'm looking at y is equal to negative x plus 2. Instead of making a chart for myself, I'm going to use the slope and the intercept. Some people find this easier. So again, whatever works for you is what you're going to use. I'm going to note that in this case, my slope is this number. When there's not a number there, I really know it's a 1. So my slope is -1, which I know is the rise, the change in y over the change in x. So it's really -1 over 1. So I'm going to go down 1 and then to the right 1. And my y-intercept here is 2. This means the y-axis, meaning the vertical one, I'm going to start at the point 2. And I put a point there. So I put a point at 2 on the y-axis, and then I'm going to move down 1 and right 1. So I went down 1 and right 1. I'm then going to draw my line, connect my 2 points, put arrows on the end, write my equation on there, and I have to ask myself, I noticed that my slope was negative. I should be doing a check in my head anytime I do any sort of question and say, is this a logical answer? When I look at this, based on my knowledge of the 4 types of slopes, yes, if I was skiing on this line, I would be going down. I would be saying nice, negative, it's easy to ski down. This is a slope of, or a graph of a negative slope. One check that I know I at least made that decision right. If I look at the next part, we're going to talk about parallel and perpendicular lines. I'm hoping people have seen this before. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocal. So an example of this, if I have a slope that's -3/4, the negative reciprocal of that would be the other sign, so positive, and then I flip the fraction. So these lines would be perpendicular, which you write like that. In parallel lines, we denote as 2 lines right next to each other. Parallel meaning they never meet. They have the same slope, they run right next to each other, but they'll never meet. So this example says, write the equation of a line that would be perpendicular and a line that would be parallel to the line y equals 3/4 x plus 7. I'm going to start with the parallel. That's easy. So parallel lines, since they have the same slope, I'm just going to write y equals 3/4 x, because I know it has to be the same slope, and then I pick any number I want and put it here. So this could literally be any number except 7. Because then I'm talking about the same line. I want a different line that is parallel. All that's telling me is it's located somewhere else on the y-axis, but the slope is the same. They'll never meet. So I can put any number there. Perpendicular lines are a little more involved. My y-intercept doesn't matter again. My slope is what matters here. So my slope, I want the negative reciprocal. So it was positive, I make it negative, and then I flip the fraction. I need the x, that's the part that's changing, and then again, any number you want here. And this one could be 7. Any number you want there. So this is really the important part. Parallel lines have slopes that are the same. Perpendicular lines have slopes that are negative intercepts.